What's poppin', grime? Today, we're going to talk about simplifying rational expressions. And you're going to love this. This is honestly one of the coolest things. And by coolest, I mean you're going to hate this because it's one of your three greatest fears in life. In case we forgot, the word rational means fractions. Just a disclaimer. The unit you are in, Unit 5, is rational expressions and equations. This is fractions, the unit. The entire unit is fractions. So you're going to have a great time. I can tell already. But don't worry. I'm here to hold your hand. I'll fill up the knowledge spoon and I'll say, here comes the airplane. Wow. And I'll spoon feed you the information. That way it's nice and digestible. I might even send it through the blender once to make sure that carrot puree that you like so much is nice and smooth. That way it doesn't hurt your tummies going down. So let's talk about simplifying rational expressions today. And then, yeah, you'll have a great time. It's actually pretty easy. Disclaimer 2, to do this, you need to know how to factor. So when mean old Mr. Barton said, if you don't learn how to factor, you're probably going to fail this class. I told you so. If you can't factor today, this is going to be really difficult for you because you have to factor. So now that you're nice and scared and angry at the system, confused about why this is necessary for you to learn, let's dive right into it, shall we? So let's go ahead and talk about a few things. The first thing you want to do on all of these, step numero uno, is going to be factor the top and bottom. This step does not always have to happen. Here, x plus 3, x minus 2, x plus 3, and x minus 3, these are already as factored as they can be because all of our x's are to the first power. So it's not necessary for you to do any factoring here. It's already done for you. So step 1 is done, but I just want to make sure we have the step written down so that we are ready for it when we get there. Okay. So now we need to do step 2, which is find our restrictions. So step 2, set, hang on, let's rephrase this. Each factor in the bottom equal to 0 and solve for x. Okay. This is going to tell us restrictions. So what you're saying is when you set it equal to 0, you're asking what number does x have to be to make this thing 0? Let's talk about why that's important really quickly. If this is 0, and let's just go ahead and fill it in, right? -3. -3 plus 3 is 0. If I plug in a -3 here, I get a -6. What's 0 times -6? 0, Mr. Barton. Excellent, students. What's 0 times anything? 0, Mr. Barton. That's what you guys sound like. That's very good, students. 0. So anytime one of these equals 0, because it's being multiplied to the other factors, it'll make the entire bottom equal 0. And then what we have is a number divided by 0. And that is one of the most illegal things you can possibly have in math. If that happens, then 1 equals 2. Your dog likes cats. Your favorite color is orange. Ugh, right? And your mom said she's not going to make you dinner and warm up your glass of milk before bed. Really, it's just not a world I want to live in. So that's super bad. So what we need to do is find those values, and then we're going to put them on a list of restrictions. We're going to say, these numbers are illegal. Don't use them. Don't even look at them. Don't think about looking at them. Don't smell them. Don't tell your kids about them. If you say them on public radio, we're going to fine you. Right? That's how against dividing by 0 we have to be. So we're going to set each of these equal to 0, find those numbers, and then put them on a restricted values list, a no-fly list. So let's do this. X plus 3 equals 0. We have to move the 3 over, so we subtract 3 on both sides. These cancel. X equals negative 3. That's one of our restrictions. X equals negative 3. It might be better to think about this as x cannot equal negative 3. You're saying this is a bad number, don't use it. Now we need to repeat that process for this factor. So we're going to say x minus 3 equals 0. Add the 3 over. Cancel negative 3 and 3. X equals 3. So that's a restriction. X cannot equal positive 3. Those are forbidden values and we're not allowed to use them. All right. Now, restrictions are anything that makes the denominator equal 0. We talked about that before you simplify. That's why it's step 2 and not step 3. Step 3 is cancel matching factors on the top and bottom. Okay. This is how we actually simplify. So let me erase this work. We already have our restrictions written down. This part is super easy. The hard part's finding the restrictions. So if we look, we have an x plus 3 in the top and an x plus 3 in the bottom. This x plus 3 on top and the x plus 3 on the bottom cancel each other out. This goes away and this goes away. What's actually happening is x plus 3 divided by x plus 3. Anything divided by itself equals 1. So we say it cancels out, but really it just simplifies to times 1 on the top and bottom. And multiplying by 1 doesn't do anything, so we don't write it. So it doesn't like eliminate, right? It just simplifies. So these go away, and then we're left with x minus 2 on the top and x minus 3 on the bottom. And this is our answer. Okay? So this is our answer with the restrictions of x cannot be negative 3 and x cannot be 3. Cool. All right. Sweet. So let's go ahead and do a couple more examples. So let's look at this one first, right here. And then we'll look at this one where we're going to have to factor. I'm not going to rewrite these steps because they take up a lot of room, but step 1 is factor. Step 2 is find the restrictions by setting the bottom equal to 0. And then step 3 is cancel. So if we look here, it's already factored for us. So we're just going to take the bottom and set it equal to 0. We add 2 to the other side. X equals 2. So our restriction is x cannot equal 2. All right, we have our restrictions. Now we get to simplify. So we look at what matches on the top and the bottom. X minus 2, x minus 2. These cancel. On the top, we have x plus 1 left over. And on the bottom, we don't have anything. So we just don't write the bottom. If you wanted to write something, you would put it over 1 because them canceling. Remember, we talked about them reducing to 1. But dividing by 1 doesn't do anything, so it just simplifies to x plus 1. So this is our answer. Pretty easy, right? All right, let's look at this second problem. Step 1 is factor the top and the bottom. The top here is already factored. The bottom has an x squared in it, though. This is a trinomial. So we need to factor this into 2 binomials where x is to the first power. So this is simple factoring because there's 1, 2, 3 terms and the leading coefficient is a 1. So we're going to go ahead and look for 2 numbers that multiply to 4 and add up to 5. So we write 4, we check our factors. 1 times 4 and 2 times 2. How can we make a 5? 1 and 4. So this will factor to x plus 1 and x plus 4. All right, we factored everything. Now step 2, we set the factors in the bottom equal to 0. So x plus 1 equals 0, subtract the 1 over, x equals negative 1. That's a restriction. X cannot be negative 1. Same thing here, x plus 4 equals 0. Subtract 4 on both sides. These cancel. X equals negative 4. So x cannot equal negative 4. That's a restricted value. So now that we have everything on the bottom simplified, we're going to cancel things that match on the top and the bottom. So on the top, we have an x plus 4. On the bottom, we have an x plus 4. This cancels with this. On the top, we don't have anything left over. So we just put a 1 there to hold the place. And on the bottom, we have an x plus 1. Now, sometimes students try and do something a little bit illegal here. They see the 1 and they see the 1 and they go, Mr. Barton, can I just cancel these? And then the answer is 1 over x. You are not allowed to do that because this isn't two separate things. You want to think of this as one single binomial. This doesn't have an x plus 1 on the top to cancel with. They don't cancel, right? If you pick a number for x, let's say 1, and we simplify this. This is 1 over 1 plus 1 is 2. 1 and 2 don't cancel out, so you're not allowed to cancel that. Yeah, you're not allowed to cancel it. So our answer is 1 over x plus 1. With the restrictions, x cannot be negative 1 and x cannot be negative 4. All right, let's do one more. This is for all the marbles. This is the last big kid problem. This one, we're going to have to factor the top and the bottom. So if we factor the top, we need two numbers that will multiply to negative 3 and add up to 2. So if we look at 3, the only factors of 3 are 1 and 3. To get a negative 3, one of them has to be negative, and we want it to be positive 2, so the bigger number should be positive. So we're going to use negative 1 and 3. So this will be p minus 1 and p plus 3 on the top. On the bottom, same deal. We need two numbers that multiply to negative 15 and add up to negative 2. So we look at the factors of 15. We have 1 times 15, 3 times 5. To get a negative 2, we're going to use negative 5 and positive 3. So on the bottom, we're going to have p plus 3 and p minus 5. Now, before we cancel anything, we get our restrictions by setting the denominators equal to 0. So p plus 3 equals 0, subtract 3. These cancel. P equals negative 3, so that's a restricted value. P does not equal negative 3. If it equals that, it breaks and it doesn't work. P minus 5 equals 0 now, setting the other factor equal to 0. Add 5. P equals 5, so we restrict this value and say don't use it. So P cannot be 5. Now that we have our restrictions, we're free to cancel the p plus 3 and the p plus 3. And our answer is p minus 1 over p minus 5. Done. And there you go. There's your notes. Yeah. Here, actually, let's add one bonus question, shall we? Let's look at p squared plus 3p plus 2 over 2p minus 3. All right. I want to show you this one just because sometimes if I don't show you one that's a little different, you guys will get to this and then panic. So step 1 is factor everything. So on the top, we need two numbers that multiply to 2 and add up to 3. So the factors of 2 are 1 and 2. And then 1 plus 2 is 3. So this will be p plus 1 and p plus 2. And then on the bottom, this doesn't factor. There's no GCF, so we just leave it as 2p minus 3. To find our restriction, we say 2p minus 3 equals 0. We just set the bottom equal to 0. Add 3 over, so plus 3 plus 3. 2p equals 3. Then we divide by 2. The 2's cancel. P equals 3 over 2. So this is our restriction. You can have fraction restrictions. That's totally fine. And then if we look here, there's nothing on the top that matches the bottom. So there's nothing to cancel. So this would be our answer. Or even if you wanted to go back one, you could multiply the stuff back together. And you could say that the original problem is the answer, and you just have to put that as a restriction. So that might happen. I'm not 100% sure that that'll happen on your homework, but I've seen it on in-person homeworks. Maybe it's like that on online homeworks. So I just want to make sure you're aware of it in case it shows up. So if you have questions, make sure you join the WebEx. If you don't have questions, make sure you like, subscribe, and hit that like button because I did such a great job of teaching you. You must love these videos. You might even like these videos. All right, I'll see you guys next time. Have a great day.